October 14, 1944, 0847 hours, Leyte Gulf, Philippines. Dawn mist clung to the jungle canopy as the monsoon clouds began their daily retreat. Colonel Hiroshi Yamamoto of the Imperial Japanese Army's 16th Artillery Regiment crouched behind his Type 96 150mm howitzer, adjusting the elevation for what he believed would be a devastating barrage against the American beachhead. His crews had spent 3 days carefully positioning their guns in concealed positions, confident that their camouflaged battery would rain destruction on the invaders before melting back into the jungle. What Yamamoto couldn't know was that high above, American counter-battery radar had already plotted his exact coordinates, and that within moments, his entire worldview about artillery warfare would be shattered forever. The Japanese had just encountered the most sophisticated fire control system ever deployed in combat, backed by industrial production capacity that would deliver more high-explosive shells in the next 3 minutes than his entire regiment could fire in a week. The strategic situation in the Philippines during October 1944 represented the culmination of nearly 3 years of Pacific warfare, with both sides fully committed to what would become one of the largest naval and land campaigns in human history. General MacArthur's return to the Philippines marked not just a symbolic fulfillment of his famous promise, but the beginning of the final phase of the Pacific War. The Japanese, under the overall command of General Tomoyuki Yamashita, had spent months preparing elaborate defensive positions throughout the archipelago, believing that their knowledge of local terrain and carefully prepared artillery positions would allow them to inflict such casualties on American forces that the invasion might be abandoned or significantly delayed. Japanese artillery doctrine had evolved considerably since the early days of the war, emphasizing mobility, concealment, and the ability to deliver sudden, concentrated fires before displacing to alternate positions. Their crews were experienced veterans who had honed their skills in China and the early Pacific campaigns, and they possessed intimate knowledge of ballistics, meteorology, and the art of indirect fire. The Imperial Japanese Army had invested heavily in artillery training, with crews spending years mastering their craft and developing an almost mystical relationship with their weapons. The Americans approaching Leyte brought with them not just superior numbers, but revolutionary technological capabilities that represented the full flowering of American industrial and scientific innovation. The development of American counter-battery fire systems had begun years earlier, driven by painful lessons learned in North Africa and Italy, where German artillery had initially dominated American forces. American engineers working in collaboration with university researchers and private industry had developed integrated fire control systems that combined radar detection, meteorological data, ballistic computation, and communication networks into a seamless whole that could identify enemy artillery positions within seconds of their first shot and deliver devastating return fire with mathematical precision. The SCR-584 radar system, manufactured by Bell Telephone Laboratories and produced in quantities that German or Japanese engineers could barely comprehend, could track incoming projectiles with such accuracy that American computers could calculate the precise location of enemy guns from the trajectory of a single shell. These radar sets, weighing nearly 5 tons each but transported with characteristic American logistical efficiency, had been deployed throughout the Pacific theater in numbers that reflected the unlimited industrial capacity of a nation that could simultaneously fight global wars on multiple continents while maintaining civilian production levels that exceeded peacetime standards. Behind this technological revolution lay human factors that the Japanese had consistently underestimated throughout the Pacific War. American artillery crews represented a new breed of soldier technician, products of an educational system that emphasized mathematics, science, and technical problem solving in ways that traditional military cultures had never achieved. These men had grown up in an industrial society where precision manufacturing, quality control, and systematic approaches to complex problems were part of daily life. Their training reflected this background, with artillery schools that taught not just the mechanical aspects of gunnery, but the underlying scientific principles of ballistics, meteorology, and fire control. American artillery officers attended courses that would have been considered advanced engineering programs in most other nations, learning to integrate multiple data sources, operate complex computational equipment, and coordinate fires across vast distances with split-second timing. The psychological preparation of American crews differed fundamentally from their Japanese counterparts as well. Where Japanese doctrine emphasized spiritual dedication and acceptance of sacrifice, American training focused on technical competence, systematic procedures, and the confidence that superior equipment and training would inevitably produce victory. This confidence was not mere bravado, but was based on concrete experience with equipment that consistently performed beyond specifications and logistical support that never failed to deliver ammunition, replacement parts, and technical assistance when needed. The mathematics of American artillery superiority in October 1944 were indeed undeniable, representing the convergence of scientific innovation, industrial capacity, and systematic training that no other nation could match. The standard American divisional artillery in the Philippines consisted of 3 battalions of 105 mm howitzers and 1 battalion of 155 mm howitzers, supported by corps and Army-level artillery that included 8-inch howitzers and 285 howitzers that could deliver devastating fires at ranges exceeding 20 miles. Each 105 mm howitzer, manufactured by companies like American Car and Foundry, with production rates exceeding 100 units per month, could fire at sustained rates of 4 rounds per minute, with burst rates reaching 8 rounds per minute. The ammunition supply for these weapons reflected American industrial abundance in ways that Japanese planners found literally incomprehensible. A single American artillery battalion in the Philippines carried more ready ammunition than an entire Japanese artillery regiment, with logistical systems capable of delivering fresh supplies faster than the guns could expend them. The quality of American ammunition represented another dimension of superiority that went beyond mere quantity. American shells were manufactured with precision tolerances that ensured consistent ballistic performance, using high-grade steel and explosives that maximized effectiveness while minimizing the risk of premature detonation or duds that plagued Japanese artillery throughout the war. The fire control systems that coordinated these weapons represented technological achievements that placed American artillery decades ahead of any potential adversary. The ANTPS-3 radar system could simultaneously track multiple incoming projectiles while directing counter-battery fire with accuracy that approached the theoretical limits of ballistic science. American fire direction centers, equipped with mechanical computers that could solve complex ballistic equations in seconds, processed meteorological data, target coordinates, and ammunition characteristics to produce firing solutions of unprecedented accuracy. The communication systems linking these elements together utilized frequency-modulated radio equipment that provided clear interference-free coordination across distances that would have challenged the best Japanese communication equipment. American artillery observers, equipped with lightweight radio sets and trained in advanced target acquisition techniques, could call for fire support and receive devastating accurate fires within minutes of identifying enemy positions. The integration of air and ground observation created a surveillance network that made concealment virtually impossible for enemy artillery, while American counter-battery fires could be delivered with such speed and accuracy that enemy crews rarely survived their first engagement with American forces. The operational reality of American artillery doctrine emphasized overwhelming firepower delivered with scientific precision rather than the careful conservation of ammunition that characterized Japanese operations. American batteries were trained to deliver massive concentrations of fire that would completely neutralize target areas rather than the precise economical fires that Japanese doctrine emphasized. This approach was made possible by ammunition supplies that seemed unlimited to observers accustomed to the severe shortages that plagued Japanese forces throughout the Pacific War. American artillery units in the Philippines expended more ammunition in single engagements than Japanese units could accumulate over months of careful stockpiling. The psychological impact of this firepower superiority extended far beyond its immediate tactical effects, creating a sense of hopelessness among Japanese defenders who realized that they faced an enemy with apparently unlimited resources and the technical capability to employ those resources with devastating effectiveness. American artillery crews developed a confidence and aggressiveness that reflected their knowledge that they possessed superior equipment, unlimited ammunition, and the training necessary to employ both with maximum effect. Enemy response to American counter-battery capabilities revealed the extent to which Japanese artillery doctrine had become obsolete in the face of American technological superiority. Initial Japanese attempts to engage American artillery followed traditional patterns of careful observation, precise ranging, and economical expenditure of ammunition. But these methods proved suicidal when facing American counter-battery systems that could locate and destroy Japanese positions within minutes of their first shot. Japanese artillery commanders quickly learned that firing more than a few rounds from any position invited immediate and overwhelming retaliation that would destroy not just the guns, but their entire crews. Desperate attempts to develop new tactics included firing single rounds before immediately displacing, but American radar systems proved capable of tracking even individual projectiles with sufficient accuracy to direct effective counter-battery fire. Japanese technical personnel who examined captured American equipment expressed amazement at the sophistication and quality of American fire control systems, noting that individual components represented technological achievements that Japanese industry could not duplicate even under peacetime conditions. The voices of American artillery personnel who participated in the Philippines campaign provide compelling testimony to the effectiveness of their equipment and training. Lieutenant Robert Morrison of the 34th Field Artillery Battalion wrote to his family that our guns can put a shell anywhere we want it, and our radar tells us exactly where the Japs are shooting from before their shells even land. It's not really a fair fight anymore. Technical Sergeant James Patterson, a fire direction specialist, noted in his diary that we're shooting more rounds in a day than I thought existed in the whole Pacific. The supply trucks keep coming, and our computers keep solving firing problems faster than the Japs can move their guns. They fire once, we fire 50 times, and their gun is gone. Captain William Hayes, commanding a counter-battery radar section, reported that we can track their shells from the moment they leave the barrel and have return fire on the way before their rounds impact. The mathematics are so precise that we're hitting targets we can't even see with accuracy that would have been impossible just a few years ago. These accounts reflect not just technical superiority, but a psychological confidence born from the knowledge that American equipment and training provided decisive advantages that enemy forces could not counter. Japanese perspectives on American artillery capabilities preserved in captured documents and post-war interviews, reveal the profound shock experienced by forces that had considered themselves technically competent and tactically sophisticated. Colonel Yamamoto, whose battery was destroyed in the opening engagement at Leyte, wrote in his diary that the Americans possess fire control systems that seem almost supernatural in their accuracy and speed. We fire 3 rounds and receive 30 in return, all landing within meters of our position. Our crews are being destroyed faster than we can train replacements, and our ammunition supplies cannot sustain the rates of fire necessary to compete with American capabilities. Major Kenji Tanaka, a Japanese artillery technical officer, noted in a report to higher headquarters that American counter-battery fire demonstrates technological capabilities that exceed our most optimistic estimates of enemy development. Their radar systems can apparently track individual projectiles with accuracy sufficient for immediate retaliation, while their ammunition supplies appear unlimited. Our doctrine of careful fire control and ammunition conservation has become obsolete in the face of enemy capabilities that make prolonged artillery duels impossible. Lieutenant Yoshiro Sato, one of the few survivors of a Japanese artillery battery destroyed by American counterfire, described the experience as like being struck by lightning that could think and aim itself. We fired 4 rounds and received what seemed like hundreds in return, all arriving within seconds and all landing exactly on our position. Civilian observers and war correspondents who witnessed American artillery operations in the Philippines provided additional perspectives that highlighted the overwhelming nature of American firepower superiority. Ernie Pyle, the famous war correspondent, wrote that watching American artillery work is like seeing the entire industrial might of America concentrated into a few minutes of devastating fire. The guns fire so fast and so accurately that it seems impossible, and the ammunition keeps coming in trucks that stretch back to the horizon. A Filipino resistance fighter who worked with American forces noted that the Americans fight with thunder that never stops and lightning that strikes exactly where they want it to. The Japanese had powerful guns, but the Americans have more guns, better guns, and enough ammunition to fire forever. British military observers attached to American forces reported that American artillery represents the practical application of industrial mass production to warfare in ways that European military thinking had not anticipated. The combination of superior equipment, unlimited ammunition, and scientific fire control creates capabilities that render traditional artillery tactics obsolete. The industrial foundation supporting American artillery superiority in the Philippines represented the full mobilization of American manufacturing capacity in ways that enemy planners had failed to comprehend. The Rock Island arsenal alone was producing 105 mm howitzers at rates exceeding 300 units per month, while simultaneously manufacturing millions of rounds of ammunition with quality control standards that ensured consistent ballistic performance. The Watervliet arsenal was producing heavy artillery tubes using manufacturing techniques that achieved precision tolerances previously considered impossible in mass production, while private contractors like General Electric were manufacturing fire control equipment with reliability standards that exceeded peacetime commercial products. The scale of American ammunition production defied comprehension by enemy observers accustomed to severe resource constraints. American factories were producing artillery shells at rates exceeding 1 million rounds per month, using steel allocation that exceeded the total steel production of Japan, while maintaining quality control procedures that ensured consistent performance and minimal duds or premature detonations. The innovation pipeline supporting American artillery development demonstrated the systematic application of scientific research to military problems in ways that no other nation could match. The Aberdeen Proving Ground was simultaneously testing new ammunition types, evaluating captured enemy equipment, and developing improved fire control systems with research budgets that exceeded the total military expenditures of most nations. University research programs, coordinated through the Office of Scientific Research and Development, were investigating advanced ballistic problems, metallurgy improvements, and electronic systems with resources and personnel that represented the mobilization of American academic and industrial research capabilities. The continuous improvement process that characterized American artillery development meant that equipment reaching the Philippines incorporated lessons learned from every previous campaign, with modifications and improvements implemented faster than enemy forces could develop countermeasures. This systematic approach to military innovation reflected American industrial culture's emphasis on continuous improvement, quality control, and the systematic application of scientific methods to practical problems. Resource abundance. Supporting American artillery operations in the Philippines demonstrated the overwhelming material advantages that American forces enjoyed throughout the Pacific War. American artillery units consumed ammunition at rates that would have exhausted Japanese stockpiles within days, while maintaining supply lines that delivered fresh ammunition faster than the guns could fire it. The logistical network supporting these operations included dedicated ammunition ships, specialized handling equipment, and transportation systems that moved thousands of tons of supplies with efficiency that Japanese observers found incomprehensible. American forces routinely discarded equipment that Japanese forces would have considered irreplaceable, while maintaining standards of maintenance and replacement that ensured consistent performance under the most demanding combat conditions. The psychological impact of this material abundance extended far beyond its immediate tactical effects, creating confidence among American forces and despair among enemy observers, who realized that they faced an opponent with apparently unlimited resources and the organizational capability to employ those resources with maximum effectiveness. The immediate tactical changes resulting from American counter-battery superiority fundamentally altered the nature of artillery warfare in the Pacific theater. Japanese artillery doctrine, which had emphasized careful positioning, precise fire control, and conservation of ammunition, became suicidal in the face of American capabilities that could locate and destroy enemy positions within minutes of their first shot. Traditional artillery tactics that relied on prolonged duels between opposing batteries became impossible when one side could deliver overwhelming return fire with accuracy and speed that made survival unlikely for enemy crews. Japanese forces were compelled to adopt hit-and-run tactics that severely limited their effectiveness, firing single rounds before immediately displacing to avoid the devastating counter-battery fire that would inevitably follow. These tactical adaptations reduced Japanese artillery to nuisance attacks rather than the concentrated fires necessary for effective support of defensive operations, while American artillery could provide continuous, accurate support that dominated the battlefield and enabled rapid advances by ground forces. The strategic realignment forced by American artillery superiority extended far beyond immediate tactical considerations to fundamentally alter Japanese defensive strategy throughout the Philippines campaign. Japanese commanders realized that their artillery could not provide effective support for defensive positions when engaging American forces, forcing them to rely increasingly on small unit tactics, fortified positions, and close-quarters combat where American firepower advantages were somewhat reduced. The resource allocation implications of American Counter-battery effectiveness meant that Japanese forces could not sustain prolonged artillery engagements, forcing them to conserve their limited ammunition supplies for critical moments while accepting American artillery dominance throughout most engagements. The timeline acceleration resulting from American artillery superiority meant that Japanese defensive positions could be reduced much faster than originally planned, preventing the prolonged campaign that Japanese strategy required to inflict unacceptable casualties on American forces. Allied coordination improvements enabled by reliable, accurate artillery support allowed American ground forces to advance with confidence that they would receive immediate, effective fire support whenever needed, while naval and air forces could coordinate their operations, knowing that American artillery would suppress enemy positions with scientific precision. The psychological warfare dimensions of American artillery superiority proved as devastating as its immediate tactical effects, creating morale problems among Japanese forces that extended far beyond units directly engaged by American artillery. The knowledge that American counter-battery fire could locate and destroy artillery positions within minutes of their first shot created reluctance among Japanese crews to engage American forces, reducing the effectiveness of Japanese artillery even when it was not directly engaged. Enemy attempts to counter the psychological effects through propaganda and exhortation proved ineffective when faced with the concrete reality of American technical superiority and unlimited ammunition supplies. The demonstration effect of American artillery capabilities influenced Japanese tactical decisions throughout the campaign, with commanders reluctant to concentrate forces or establish positions that might attract the devastating fires they knew American artillery could deliver. The long-term confidence and capability perception changes resulting from encounters with American artillery created a sense of technological inferiority that affected Japanese morale and tactical aggressiveness throughout the remainder of the Pacific War. The immediate impact of American artillery superiority on the Philippines campaign contributed decisively to the rapid collapse of Japanese defensive positions and the acceleration of American advances beyond original planning schedules. Specific battles like the reduction of Japanese positions on Leyte and Luzon demonstrated the devastating effectiveness of American counter-battery fire, with Japanese artillery units being systematically destroyed within days of initial contact with American forces. The ability of American artillery to provide continuous, accurate support for advancing infantry meant that Japanese defensive positions could be reduced with minimal American casualties, while Japanese forces found themselves unable to provide effective fire support for their own defensive operations. Enemy acknowledgement of American artillery superiority appeared in captured documents and prisoner interrogations throughout the campaign, with Japanese commanders reporting that their artillery had become ineffective against American forces and requesting tactics that might allow them to avoid direct engagement with American counter-battery systems. Post-war recognition of American artillery achievements in the Philippines came from military historians and former enemy commanders who acknowledged the decisive impact of American firepower superiority on the campaign's outcome. General Yamashita himself noted in post-war interviews that American artillery capabilities had exceeded Japanese estimates and had rendered traditional defensive tactics obsolete, forcing Japanese forces to adopt desperate measures that reduced their effectiveness and accelerated their defeat. Historical analysis of the Philippines campaign consistently identifies American artillery superiority as one of the key factors enabling rapid American victory, with particular emphasis on the counter-battery capabilities that neutralized Japanese artillery and allowed American forces to advance with minimal casualties. The technological legacy of American artillery innovations developed during the Philippines campaign influenced post-war military development and established principles of fire control and counter-battery operations that remain relevant to contemporary military operations. October 14, 1944, 0850 hours, Leyte Gulf, Philippines. Colonel Yamamoto's Type 96 howitzer lay twisted and silent, its crew scattered by the devastating accuracy of American counter-battery fire that had arrived within 3 minutes of his first shot. The mathematical precision of American fire control systems had transformed artillery warfare from an art into a science, while American industrial capacity had provided the unlimited ammunition supplies necessary to make that science devastatingly effective. This wasn't merely technological superiority, it was the practical demonstration that American industrial democracy could outproduce, out-innovate, and outfight any military system based on spiritual dedication alone, and the echo of those guns would resonate across the Pacific until the final surrender in Tokyo Bay. If you found this deep dive into American artillery supremacy as fascinating as we did, make sure to like this video and share it with anyone interested in military history. Don't forget to subscribe and hit that notification bell for more untold stories of American technological and industrial dominance in World War II.